Good morning, everybody. Welcome to class this morning. First of all, I just want to thank you for watching our class today. Whether you're watching it here with me live or you'll be watching it later on, the recording. Thank you for watching. Thank you for tuning in. I hope you're finding these live streams incredibly valuable. I mean, we do discuss a lot of information that is very pertinent for how you progress in the course. And another thing that I like to do in these live streams is give some announcements. So I've got some housekeeping things to start off the class with today. One is that your Module 1 assignments have been basically graded. I think I have one left that I have to deal with finishing up grading on. But my policy is that I try to get everything graded within 7 days of the due date. So within 7 days of the date the assignments are due, I will have those graded and returned to you. So what isn't done there should be done within the next day or so. Also, another thing that I want to point out, since the Java class is an upper level class at Cleveland Community College, some of you might be planning on graduating this semester. As an individual who's planning on graduating this semester, if you are planning on graduating this semester, you want to make sure that you go ahead and fill out your graduation application and get that in. Also make sure that you are signing up for any certificates that you might have earned as well. You know, one of the things that we like to do with our information technology program is we like to stack all that stuff on top of each other. So when you graduate with your associate's degree, you're probably also supposed to have 2, 3, maybe even 4 certificates as well. So you want to make sure that you're getting everything that you're supposed to be getting so you can put that on that resume and work with that going forward. So that's for those of you who are planning on graduating this semester. The graduation application deadline is coming up very quickly, so you'll want to work with your advisor on getting that in. But today we're moving on into Module 2. And in Module 2, we're talking about putting data into buckets, and we're using variables as our data bucket. And I'll talk more about what I mean about a data bucket here in just a minute. But what I'd like to do today, my kind of agenda for today, is to cover some material, go through, do some little examples, and move forward with what we've got going on. And as always, remember that if you're watching here live with me, you can put questions in the chat if you have them. If you're watching this recorded, send me a message on Teams, send me a message via email with your questions, and we will work those out. Well, we're talking about variables today, and using a variable in programming is a huge deal. It's really what takes our programming and starts progressing it. You know, in Module 1, the assignment was supposed to be really easy, and I think a lot of you found it really easy. You know, the ideas were just writing a few system.out.println statements just to get you acquainted with utilizing the online environment for programming that we're using, just writing just a little bit of code, just to kind of get, dip your toe into the water just a little bit as we get started, have a nice little introduction to Java. And now as we progress, one of the things that I like to say about programming classes is that they're a lot like a snowball rolling down a hill. Right? At least that's the way that I like to approach them. As we start, we're doing small little tasks, and we're building on these small little tasks each week. And as we progress, things start to get bigger and bigger and bigger, and these small little things that we have been learning week after week, we can start to use them together to create bigger and bigger programs to solve our problems. And so our variable is our first real element that kind of takes us into that area of programming and doing more with programming. So the first thing that we wanted to define here is just what is a variable. And one of the ways that I like to describe a variable, so if you're in more classes with me, you'll hear me talk about a variable in these sorts of terms in basically every class where we're learning a programming language. Where I like to say that a variable is a container or a bucket, or you can think of it like a box for data that we're wanting to use in our program. And when we create this container, essentially what we're doing is we're creating ourselves a container and we're putting a label on it. And that label is the name of our variable. Right? So when we declare our variable, which we'll talk about what that means in a little bit, we're establishing that bucket and we're putting a label on it that's going to be the name of that variable. Then what we can do is we can take data and assign it inside of that bucket. So from that point forward, what we have is a symbolic relationship between the name of that container and the data that's inside of it. And this is super important. Like, one of the things that we want here is to have this symbolic relationship, because not only are we able to refer to that data by that bucket name or by that container name later on in our program, so we don't have to refer to the data directly, but we can also manipulate and change our data in our program on the fly through a process that we call reassignment. And that's when we take a currently existing variable and give it a different value at some other point in the program. So these are all critical things that are very important to using a variable. And we're going to start out really slow with using variables, but as we progress, these processes of establishing variables and reassigning variables is like one of the biggest things that we can do. So even though it's one of the most standard concepts that we can learn, it's also one of the more important concepts that we need to have an understanding of going forward. And so when we have a variable in Java, there are 6 properties that are associated with a variable. One is the variable name, another is the variable type, another is the variable value. Then we have scope, lifetime, and location in memory. Now, for our purposes, since this is sort of an introduction to Java class, we are just going to focus on the first 3 variable properties in this course. And really, it's all you kind of need to get started with Java. Right? We'll pull in scope a little bit later when we start to get into methods and things of that nature. Because when you have a variable inside of a method or a function, in Java we call them methods. In other programming languages, you might call them functions. We can use those terms interchangeably. When you have a variable inside of a function, it is scoped to that function, but you can also have a variable that's scoped to the class. So later on in the course, we'll talk more about how we utilize objects to change the scope of our variables. But for now, as we're just getting started with variables, we're just going to focus on these first 3, name, type, and value. Now, when we're naming a variable has some specific rules. One is that we must begin our variable with either a letter, an underscore, or a $sign. So when we're creating a variable in Java, it has to start with either a letter, an underscore, or a Java sign, or a $sign. Any other character, like if you try to use a number or any other symbol, you'll get an error. It won't work. In order to name a variable in Java, we need to start it with a letter, an underscore, or a $sign. Now you might be thinking, well, why can't I start it with a number? Like you say here in bullet point 2, after the first letter, you can include numbers if you want to. And this is all based on how our interpreter is reading our program. When our interpreter sees a number at the start of something, it thinks, oh, well, I'm about to do math. This is kind of an overly simplified version of this, but you understand. It's it's to help you get it. It sees this number at the start of our variable, and it thinks, oh, I'm about to do math. But then it sees the rest of these letters that are following this number, and it says, oh, wait, that's not math. What is that? I'm confused here. What is this? I don't know what this is. So you get an error message. So when we're naming our variables, we want to make sure that we are using either a letter, an underscore, or a $sign to start our variables in Java. And then after that first letter, after that first character, you can use numbers if you want. Now, you also can't use spaces or special characters. The only special character that you can use in your Java variable is the underscore. Now, we can make the name of our variable any length, but we want to try to keep it short, because if we have super long variable names, then it kind of defeats part of the purpose for having variables. And another thing is that they are case sensitive, and this goes back to something that we were talking about previously with our ASCII chart. So you might remember before we were looking at that ASCII chart to talk about the differences between our uppercase and lowercase letters, how an uppercase T and a lowercase t are two different things, according to our interpreter. Because with the way that our computer reads letters, it's not just reading the letter. Like you and I are smart enough to be able to look at an uppercase letter and a lowercase letter of the same letter and say, yeah, that's the same letter. But our computer doesn't read letters in the way that we do. Our computer sees a letter, it decodes that from the information that it gets from an ASCII chart so that it can code it into binary, which is a language that our computer can understand. So an uppercase T and a lowercase t are two entirely different things when it comes to the way our computer understands them. Like an uppercase T has a value of somewhere around 84 on the ASCII chart, and the lowercase t has it somewhere around 116. I don't quite remember. I'm not looking at the chart right now. So the case sensitivity of our variable names is incredibly important. We have to be specific and we have to be consistent for our computer to understand what we're talking about. And our final thing that we have is that we don't want to use Java keywords. Well, what is a Java keyword? These are words that are already reserved by the program for another purpose. So if we look at a list of these keywords, I mean, there's a lot of them here, but it's not really a ton of words in relation to all of the words that exist in the human language, right? These are words that already have a purpose in Java. Abstract, assert, Boolean, break, byte, case, catch, char, class, const, continue, default, do, double, so on and so forth. You see them all here. If you need to, like I'll take and make this full screen for a minute. You could take and pause the screen here and read it. I think I also have these in your reading in the module. But these are all of our Java keywords. So all of these words already have a purpose in Java. So we can't try to use them for another purpose because they already have a reserved purpose. So while these are a lot of words, in terms of the grand scheme of things of the words that we're able to use in the English language, we have essentially unlimited variable names even without this set of reserved names. We just have to be careful when we're naming variables that we don't get into one of these. Now I've got this slide here, and if we were in the same room, I would pause here and I would ask you to answer these questions of will it work? And so I've got these different variable names here, and I'm just asking, this is kind of the interactive portion, because I have these variable names. And I'm asking you if these variables work. So if you're watching this on the recording, you can pause here. If you're watching with me live, I'll give you a couple seconds here before I show the answers and explain why they're the answers. But what we're asking here is whether or not these variable names will work as a variable name in Java. Some of them will, some of them won't. So take a couple seconds, maybe, write it down in front of you if you've got a notepad in front of you, or just kind of think about it and have the answers in your head. Think about the answers to these questions as to whether or not this would work as a variable or it would not work as a variable. We'll give you, for those watching this, you can pause here. For those who are watching live, I'll give you about 10 seconds starting now. All right, so let's talk about what the answers are here. We'll pull them up. First one, just the word grade. Even though it starts with a capital G, that's fine. That is a yes, right? It's just the word grade. Grade is not a reserved keyword. It is not used anywhere else. It starts with a capital letter or an uppercase letter, which is fine. It just means that whenever we refer to grade, this grade variable, later on in our program, we have to also refer to it with the capital G. Now we have this grade and in parentheses test, and this is not a valid variable name. Remember, we said we can't use special characters in our variable names. So these parentheses here do not count. We can't use them in our variable name. Grade underscore test is valid. Remember, we said that the exception to the no special characters rule was the underscore. So this is a valid name. We just have to make sure that when we're referring to this variable later on in our program, we have the capital or uppercase G in place, the underscore in place, and the uppercase T in place. We want it to look exactly the same everywhere else in our program, wherever we write it. Now, in the next one, number 4, and then the word test, no. Because remember, we said we can't start a variable with a number. Default, well, that's a no, because that is one of those reserved keywords that was just on our last slide. There it is. So that's a big no. And then finally, $grade. We can start our variable names with a $. Even though we can't use a $sign inside of our variable names, we can use one at the start, because the $sign is kind of like this universal symbol notation for a variable. Like if you get into some other programming languages, you actually need to use the $sign. Like if you start programming in PHP, the $sign is required for a variable. So they baked that into the Java programming language. So people coming from other programming languages where you had to use the $sign, or where you were used to using the $sign, you would still be able to ease right into doing that. Now, along with these variables and having these variable names, Java is what we call a strict typed language. Meaning that when we're using a certain type of data, we need to tell our program that that's the type of data that we're using, whether it is in a variable or in a method or whatever. We need to tell our program that it is a certain type of data. And so we have a list of our data types here. And so when something is strong typed, our variables have to be explicit or declared. So we have these specific data types here. And I've kind of bolded the ones that are going to be the most important to us. Right? Like you have byte and you have short. And these are both for numerical data that is 1 byte. So like a byte is going to be basically something in binary. It's going to be a 0 or a 1. A short is going to be 2 bytes. For the majority of our purposes, especially for the scope of this class where we're kind of just getting started, you're not going to use these. The first thing that you're going to start to use is the integer variable, or int. And this is for a whole number, anything from negative infinity to positive infinity, as long as it is a whole number. And this can store 4 bytes of data in it. Now, if you need a number that's bigger than that 4 bytes of data can hold, you can move on to a long. A long is an integer, it's just long, right? So it's a whole number between negative infinity and positive infinity, but it's going to be a longer whole number. Our integers can hold pretty long numbers. Like for the majority of our purposes, we're not going to need a long. It's only when you're starting to get into big numbers where that int data type is going to not accommodate you as well, and you're going to need that long. Now, the next thing that we have is the floating point number. And this is you might call these a decimal number. These are numbers with a decimal point and then numbers after the decimal point. And oftentimes when we're doing math, if it's something that's going to have a remainder, like if we're doing division, and it's something that could have a floating point or a decimal, then we want to start out with floating point numbers. So it seems kind of counterintuitive if we are taking 2 numbers and putting them into our program, and the ones that we're putting in there are integers. If the potential result of the math equation is going to be a floating point number, then we're going to want to make sure that we are starting out with floats. Now, in contrast to our integer, we actually won't use float that much. In its place, we'll use double. Double is to float like long is to int. So double is for a longer floating point number. But we're going to use double over float in pretty much all cases for the purposes of precision. Because the more numbers that we can go out past that decimal point or past that floating point, it's going to provide us with more valuable information. So in the vast majority of our programs, for regular whole numbers, we're going to be using int. And for floating point numbers or decimal numbers, we're going to be using double. Then we have char for a single character. Boolean, we'll talk about Boolean variables a little bit later on. They'll become exceptionally more important when we get to loops and conditions. So we'll kind of put a pin in Boolean for right now, and we'll circle back around to it later. But with Boolean, essentially something is either true or false. There was a mathematician by the name of Boole who essentially said that every single math equation can be solved by a series of true or false answers. And so that's where we get this idea of something being Boolean. It is essentially a binary where something is either true or it is false. So you have a proposition, and in terms of symbolic logic, proposition is something that is unambiguous, that we can say that it is either true or false. If you've taken the Introduction to Programming and Logic course, we talk about that in that course. So the Boolean comes as a direct result of one of these proposition statements. We're able to evaluate a proposition and determine whether it is true or false. And then finally we have a string, and a string is just a sequence of characters. So any numbers, any letters, any symbols that we put between a set of quotes, once we wrap those quotes around them, that's when these characters become a string. And string is a little bit different in terms of the way that we declare the rest of our primitive variables in Java. And we'll talk about that a little bit later on. But so now that we know data types and we know our naming structure, we can start to talk about declaring a variable. And so when we're declaring a variable, this is essentially establishing that container and giving it a name. Now, in Java, we also have this added wrinkle in there of kind of giving it a filter, right? Because we can kind of think of our data types as a filter when we're establishing the container. Like if I'm saying that I'm going to create an integer variable or an int, then I'm essentially saying only integers, only whole numbers are allowed to go in this container. And when we get into utilizing variables, we'll see that it's essentially, the declaration is essentially everything on the left-hand side of the equal sign. So we'll utilize the data type, and then we'll utilize the variable name. And we'll do all this in an example here in just a few minutes. I want to get to a good point with our slides here before we go into the next thing. So after we've declared a variable, we can assign a value to it. And when we assign a value to it, essentially all we're doing is we're giving a variable value through assignment. We're taking some kind of data and putting it in that container. So we use a single equal sign to set a variable equal to some sort of data in assignment. Now, I said strings were a little different, and we'll see this in a little bit. With strings, essentially what we're creating is a string object. And so with strings, what we're doing is we're assigning the variable value through something that we call a constructor. So let's start out slow with a little example here, and then we'll move on to something a little bit bigger. So I'm on REPL.it here. And as we're doing this, I think this is a good time to remind you of how this works, right? So remember that for your assignments, you're going to our team. For your labs, you're creating a new REPL. So what we're going to do here is we're going to create a new REPL. We're going to treat this like a lab. You'll get your languages here. Since you've written a Java program already, you should have Java in your favorites. And then you're going to give it a name. And this, I'll call this intro with variables. And we'll create this REPL. And again, one of the things that we looked at last week in our live stream, one of the great things about our REPL is that it starts us off with the hello world. System.out.println hello world. And so it starts us out with functioning code, which is good, right? Especially when we're learning. Having a basis that already functions is going to help us out a lot because we have something here that we already know to work. So the first thing that I want to do is I want to declare and assign a variable here for one of our primitives. And when we're talking about primitives, we're talking essentially about our integers, our doubles, and our booleans. The variables that we're going to use for numbers, and the variable that we use for true or false. So what I want to start out with is just building a basic equation using operators with variables instead of just building out the equation. So one of the things that I might do is create a program that helps us get the area of a rectangle. Or not, we won't start out with area, we'll start out with perimeter, right? Let's start out with perimeter. So let me zoom in here. Now again, here are a couple things to notice. We'll talk about them again this week. We have our class here, and our class is related to our file. So we make sure that our file name here is the same as our class name. And in REPL, it's always going to be main and main. And then we have our main method. And the main method, everything that we do right now is going to be done inside of the main method. When we start talking about writing our own methods, we'll start talking about how we can write new methods and have them executed in the main method. But the main method is the place where we put all of our code that needs to execute. So like if you remember back, if you took Introduction to Programming and Logic last spring, and you remember me talking about the main gate in Python, and how we would write all of our functions at the top and we put our code that we would execute at the bottom behind the main gate. This is a similar concept. The big difference being that our main method's actually required in Java versus it being optional in Python. And so we can run this here and we can see our hello world. Hello world, there it is. And so we know we have some functioning code here. So we can actually take advantage of this functioning code. So we're going to write a program here for perimeter of a rectangle. And we're going to see what we can do with that. So what I'm going to want to do is I'm going to want to create a variable, and I'm going to want it to be, I'm going to want to have a variable for side A. I'm going to want to have a variable for side B. And then we're going to do some other stuff to get our program going the way that we want it to go. So let's create our first variable here. We'll create our first variable together. And remember that essentially what we're doing when we're creating a variable is we are establishing this container. We're putting a label on it. So if I want a variable that's side A, I can create a variable with a label. I can create a container with a label of side A. But remember that Java is strictly typed. So one of the first things that I need to do here is I need to write the data type that I'm going to be putting into this variable. Now, since we're doing perimeter and not any kind of advanced calculations, and we're just getting started with this, we'll make these integers. When we get more advanced in the future, we might want these to be floating point numbers. You know, if we're doing more advanced numbers or we're allowing for user input, then we might want to use floating point numbers so that we can do a little bit of planning for errors and that sort of thing. But in this instance, since we're just getting started, we know the numbers that we're going to use because we're going to be defining them ourselves instead of having a user define them. We can just create ints. So integer side A. And that's our declaration. We've established this integer variable now. This integer variable container with the label of side A. And I can set that equal to some number. We'll say 15. Semicolon at the end of the line because it's Java. That semicolon, remember, we talked about that last week, terminates our line. It's like the period at the end of a sentence. And so we see that little green squiggly under our side A now. And that's because we've declared this variable, but we've not used it yet. And so we've declared this variable, we've assigned it a value of 15. So remember that when we do declaration, that's essentially what's on the left-hand side of the equal sign, and assignment is what we put on the right-hand side of the equal sign. Now in Java, we can actually declare and assign separately. And there are some times when we'll need this, and we'll get into that a little bit later on. But for example, what I'll do is I'll do that with side B. Right? So I will create a declaration int side B and go ahead and terminate it. Semicolon. Now what that's done is that's created my container. I have this container in memory with the label on it of side B, but I've not put any data into it yet. So I still need to write some kind of assignment statement that's going to put data into that variable. So I would have to write some kind of assignment statement where I'm assigning data into this variable. And from this point, I can say side B equals, we'll say 8 for our purposes now. I don't have to put the integer again, because I already established that when I initially declared my variable that this is an integer container. So once I declared that variable the first time, I don't have to declare it again. It's already declared. What I'm doing here is just assignment. I'm taking some data and putting it inside of an already existing bucket. So we can declare once and assign multiple times, right? Like I can take and I can reassign this variable via reassignment, and I can say side B equals 6. Now at that point, as my interpreter is reading through this program, it's going from the top to the bottom in our main method. So it's going to say, okay, int side A equals 15. So we've got a variable of side A. It's got the value of 15 in it. Int side B, okay, so we've got a container, a variable for side B. Side B equals 8. Okay, we're putting 8 in that container. Side B equals 6. Oh, now we're taking that 8 out of that container and putting the 6 in. So if we were to print out side B at this point, it would be 6. But that was just a brief sidebar. We're going to go ahead and remove that for our purposes here. And so what I would want to do here is there are several different things that I might want to do. Like I could go ahead and double each side, right? Because if you're getting the perimeter of something, you need all the way around. And if we're saying this is a rectangle, then we might want to go, then our adjacent sides, the sides that are across from one another, are going to be the same length. So we'll have 2 sides that are 15 in length and 2 sides that are 8 in length. Another thing that we could do is we could also just add these two together and then multiply by 2. Right? So let's do that for our purposes here instead. So what I'll do is I'll create another integer variable, creating another variable because we're practicing variables. And we'll give this the name of perimeter. And we'll set it equal to, in parentheses, side A plus side B times 2. Semicolon to terminate the line. So now you can see that our little squiggles under side A and side B have disappeared because we've used them in something else. Right? So as our interpreter is going through this, it's getting this perimeter line here, and it's saying, okay, side A. I know that variable. I'm going to go back to that container, grab the data out of it, and put it inside of that variable. And then it's seeing side B, and it's just saying, okay, side B. I know that variable. I'm going to go find that variable, side B, put it, whatever's in that container, I'm going to bring it back here. So it's essentially saying, okay, this is a 15, this is an 8. So as of right now, relatively simple, but as we progress, the way we use our variables and the way we're able to do reassignment on the fly will become more important and make it a little more complicated. So now all we really have to do here is we have to print this out. So we've already got our functioning system.out.println here. So all I have to do is put my variable name in between the parentheses here, perimeter, and that's going to print out the results that are assigned to my perimeter variable after it does the calculations of side A plus side B times 2. And just another thing to point out here as we're kind of progressing, that we put side A plus side B in parentheses because we talked about last week, PEMDAS rules, order of operations. We want to make sure side A and side B get added together first before we multiply by 2. That way we get the full parameter. Because otherwise it's going to follow the order of operation, so it would multiply side B times 2 and then add side A. So we'd have a whole side that would be the equivalent of side A that wouldn't be accounted for. So what we should expect when we hit the run button here is for everything to go into our new variable, do the math. It's going to return the result of the math to this variable. That's what's going to be put inside of this container, which should be, if we do the math ourselves, this is why we start with easy programs, because we can do the math ourselves and check the results. So 15 and 8, that is 23. 23 times 2 would be 46. So if we run this, we should expect to get 46 in our console here. Now I can clear this out by pressing that button there, just so we have a nice clean console again, and I can click run. So it starts to run it, it compiles it, and it gives me 46 as my answer. So this is exactly what I'm looking for. So that's essentially how we do that. Now we can also put a string in here. And we set a string's a little bit different. Like if we're doing a, if we're doing an integer, we do it this way. If we're doing a float or a double, let's create a double variable here. We'll just call it example double. We're going to set that equal to some kind of floating point number, 5.12375. Close that off, semicolon to end that. But our string we write a little bit differently. Our ints are written the same, our doubles are written the same, our booleans are written in the same manner. We would just say like bool Boolean something equals true. And so that's going to give us a Boolean variable. But when we write a string, and a string variable, our string is not considered a primitive in Java, so we have to write it just a little bit differently. And we use constructors to write string variables. So for this, since we're practicing our variable declaration and assignment, I will write ourselves a string variable. We'll make more than one. One to kind of be the title of our program, and another to that we can concatenate with what we have in our system.out.println here. So in order to create a string variable, we need a string constructor. So we're going to say capital S string, and we'll call this one like program title. And we're going to set that equal to a new string. So we're creating a string object is essentially what we're doing here. So we're using the constructor declaration or constructor object declaration here to create our string variable. And so then we'll put in parentheses what we want the value of this to be. So a string is a series of characters. We can use certain characters for decoration. Like if I want to go 1, 2, 3, 4, 5, 6 colons, perimeter of a rectangle, and then 1, 2, 3, 4, 5, 6 colons. Now I have a little string variable that I can use at the start of my program. And so again, this is a little bit of an overly simplified example, but it helps you kind of move in the right direction, right? So I can just write another system.out.println here, system.out.println. Remember, our interpreter executes everything in order from top to bottom. So if I want the title to go before my number in the output, I need to put it first. And we can just program title here. And then we'll make sure we are putting our semicolons at the end. More often than not, if you have an error in your program, especially in Java, it's going to be some type of typo where you have capitalized or not capitalized something that you should have, or missed a semicolon or something like that. So now when we run this, and I'll go ahead and click this clear button to empty my console here, I can run it. And I can see, get my perimeter of a rectangle here, and we say 46. Now, we've looked at mathematical operators, and mathematical operators are pretty simple. Plus, multiply, divide, minus. One of the ones that you might not be as familiar with that is in your module material is something that we call modulo. And it's represented with the percent symbol. And the result of a modulo equation is the modulus. And essentially what this is a division problem where instead of the result, you get the remainder. So if I said like 4 divided by 2, my answer is 2. But if I said 4 modulo 2, my answer is 0. Because there's no remainder after 2 going into 2. Conversely, if I had 5 modulo 2, my answer is 1. Because 2 goes into 5 twice with 1 left over. So that leftover is what we're working with here with our modulo. So with all of our numbers, with our integers and our floating point numbers, we can do math the way that we did here. But with strings, since strings aren't a number, we can't do math with them. They're just a series of characters. Even if we create a string that is numbers, if we put it in between quotes, it becomes a string and we can no longer do math with it. Right? But we can use that plus operator with strings. And then it becomes what we call concatenation. So what I could do here is I could create another line and maybe say system.out.println quotes side A length. So we have a string there called side A length. And what I'm going to do is I'm going to put a colon and a space at the end of that. Remember that our strings are every character that we put in our string is in that string. So if we want a space in our output, we also have to put it in our string. So if I want a space between this colon and whatever I'm going to put after it, I need to put a space in my string in my program. But I'm going to concatenate this with our side A variable. So what that's going to do is it's going to create one long sentence that takes side A length and tack on to the end of that the value that's in side A. So I could write another line and do the same thing for side B. Since we already have something that could be successful, we can just tack that on like that, side B length. And we'll add side B. And we can also concatenate string variables. So if I wanted to create myself a new string variable, call it string, capital S string, output info, and we'll set that equal to a new string with the value of the perimeter of the rectangle is, and make sure we have our semicolon at the end of there. Then I can take that output info, concatenate that with perimeter, output info plus perimeter. Then I could even add something to the end of it here. I can concatenate as many strings together as I want to concatenate together. So I could add something else like units. Now notice there we have a space at the start because I want a space between my perimeter number and units. So now essentially what we have here is we have a more robust, more complete program. And the primary purpose of this was demonstrating the creation of variables. So we created more variables than we probably needed to in this demonstration. But having variables and doing operations in variables like this actually helps us out a lot. Because one of the things that we could do is we could save that operation for the end. Right? And we could take everything and we could put it into one print statement. But if you get something wrong, it's harder to tell where you got something wrong if you're taking a bunch of your code and squishing it together. If you're able to do things in different variables and in different methods, we'll talk about later on, we actually have a name for that. It's called composition. And if you can take your program and break it out into smaller parts and put it across multiple variables, and later on multiple methods when we get to methods, that's going to help you isolate your problems. It's going to help you do something that we call incremental testing, which we'll talk more about later, so that you can test along the way so you have a more clear picture of what's gone wrong if something has gone wrong. But from here, we can click Run, and we can see the results of our program. Side A length 15, side B length 8. The perimeter of the rectangle is 46 units. Now in this instance, since we're still using static declarations, we haven't introduced the concept of inputs yet. If we want to change that, we can come back in here, change the value in these variables. So maybe I want to make that 9, and I want to make side B 23. Click Run. It's going to do the entire process. So that's that's the gist, and that's a good example of some different things that we can do in Java here. Now I'd like to look at a couple more concepts before I turn you all loose for the day. Just to kind of reinforce some of the things that we just did. One of which being operators. We talked about operators, plus, minus, multiply, divide. And there are some more advanced operators that we'll use for other purposes, like our modulo, and we'll talk more about them a little later on. We'll actually use them in some programs. Modulo is actually incredibly useful for certain things. And then it follows the order of operations, so we just talked about that. One of the important things to remember is that there are rounding errors with floating point numbers. Floating point numbers in Java are approximate. Now they're good, like they're good data, but they're also approximate. However, when we're working with repeating numbers that repeat into infinity, or we're working with irrational numbers, they have to be rounded. And the difference that we get between the number that we're supposed to have, or the number that we want, and the number that we get is called a rounding error. And the problem all lies around this one specific number, 0.0 or 0.1. 0.1. 0.1 is a terminating fraction in decimal. However, when we convert that to binary, it is a repeating fraction. So it repeats on infinitely. So if you've ever heard that old meme where 0.9999999 equals 1, this is where it comes from. The idea of 0.1 and how the way that we as human beings deal with 0.1 is different than the way the computers deal with 0.1. And there are ways to solve this, and there are ways to get around this, and we'll talk more about them a little later on. But at this point, we're just bringing this up to make it clear that our math isn't always 100% like exactly what we need. Now, we're going to get incredibly close. We're going to get probably, especially for everything that we do, we're going to get closer than, we'd have to. But if you're working in something where incredible precision is of the utmost importance, then you're going to want to incorporate some other more advanced methods of error handling in terms of making sure that our decimal numbers are what we want them to be. And so really, everything else here that I have is stuff that we've talked about during the demonstration. We're also approaching an hour here, so I'm going to go ahead and stop here for the day. I think we've had a long enough live stream for one day. And I think you're also already equipped, just based on our little example, the stuff we've covered here, plus the stuff that we have in the module, to tackle the assignments that we have for Module 2. So I think we have everything in place that you need. Remember that if you have questions, if you need information from me, please feel free to email or send me a message in Teams. I'm going to hang out in chat for just a couple minutes here, just in case anybody who is watching live with me has any questions. But if you're watching this later and you have questions, email, Teams, let me know. Remember that your Module 2 assignments are due by Sunday at 11:59 p.m. That's all that I have for you for this live stream. Thank you for watching, and we'll see you next time.